Okay, so question 24 from the same paper, I believe 2020. And this question's asking us the points A, B, and C lie in a straight line. The length of AD is X. D is the center of the arc AB, and B is the center of the arc CD. Okay, so that's the arc, that's the arc. Find the total shaded area in terms of X and theta. Okay, so first things first is that this distance is X because that is the radii. Center D, AB, that's the arc formed from D, yeah? Now, it does look like it's not to scale, so that does look exaggerated, but yeah, we'd have to see that that's X, that's part of the circle, okay? So it would extend like that, and X are both radii, okay? Good, that's told. D is the center of the arc AB. B is the center of the arc CD. So in the same way, this would also have to be X, because we know that BD has X, and BC also must be X, because they're both radii from the same circle, as you can see there, okay? I won't leave that there because it just messes, it makes things a bit more complicated. But you can see the two sides, X, X. Now, we don't know this angle here. We can maybe just label it as alpha, okay? An angle alpha, which we don't know. So find the total shaded area in terms of X and theta. So of course, we don't want alpha, okay? So let's see if we can at least try to get alpha in terms of theta, because we want the answer in terms of X and theta, and obviously alpha is just something we introduced ourselves. So this is an isosceles triangle. So these two sides we'll know, let's say is y. So y plus theta will equal to 180. So 2y plus theta will equal to 180, which means that y will equal to 180 minus theta over 2. Now y plus alpha equals to 180. So alpha will equal to 180 minus y, which will be 180 minus, always good to use brackets here, just to make sure you apply that minus sign to everything, minus the 180 minus theta over 2, which is the y there. So 180 minus 180 over 2 is actually 90. And then 180, that's that accounted for. Minus times minus theta over 2 will be plus theta over 2. So we have alpha in terms of theta. And now we want the total area of the shaded area. Now, the shaded area is actually a segment equals to a sector minus the triangle, okay? So we could do it in terms of regions, actually. That is an option, but I'll do it with more conventional formulas, okay? So the conventional formula, if theta is in degrees, will just be the area of the segment. So it's area of segment AB, segment AB, I guess, will equal to the sector DAB minus the triangle, okay? Which is the same, call it triangle DAB. So that sector will be theta over 360 times by pi r squared, which is pi x squared, okay? And then the triangle will be from the area of a triangle, which is half AB sine C. In other terms, half times two sides joining together and the angle between them. So it will be half x squared theta, okay? So that's from this one formula, half AB sine C, okay? Area for a triangle. Yeah, so they want you to know that for PAT, and that's okay. That's done. And then the area of BCD similarly can be done in the same way. So the area of the segment. This is the shaded bit, by the way. The segment BCD. Well, again, at this time it will be alpha over 360. Okay, so it will be 90 plus theta over 2, which is the alpha over 360 times by pi. Again, we have the same radii, which is x squared. So times by the pi x squared minus, again, half x squared, but the angle this time in between, because remember it's half AB, the two sides, sine the angle in between. Two sides, and the angle in between was the alpha. So that will be sine the alpha, and the alpha will be 90 plus theta over 2. Okay, now this question is quite loose-ended. It just says find the total shaded area in terms of x and theta. It doesn't even tell us if the theta is in degrees or radians. If it's in degrees, then it will be theta over 360. If it wasn't in degrees, then you would have to use the radian version of this formula, which will just leave it as theta. Okay. So from there, so the total will just be the sum of those twos. Okay. So it will be pi x squared theta over 360 times that by 2, top and bottom. So it'll be 180 plus theta over 360 minus half x squared. And then sine theta plus sine 90 plus theta over 2. Okay, that's it. Great, excellent. Okay, so I wanted to show us this equation if you were to do in radians, and I think the PAT might actually prefer you to do it in radians because the formulas are a bit easier. But if you are not able to, then that is fine. That's an acceptable answer because it hasn't said degrees or radians. I would just make a note and say theta in degrees. Okay. Now in radians, what we do is the formula for the area of a sector in radians actually easier, which is half r squared theta. Okay, so segment AB will just be half r squared, so there's no pi. So it would just be half r squared, which is x squared times by theta. Okay, and then minus, that would have to stay the same. So it would still be half x squared sine theta for triangle. And then the segment BD will be the same, but with alpha, isn't it? So half x squared 90 plus theta over 2 minus half x squared sine theta plus theta over 2 plus 90. Okay, and that would be it. We just have to combine them. So the total, we can see half x squared is everywhere. It will be half x squared, and then theta plus 90 over sorry, theta plus 90 plus theta over 2 minus the sine theta, which is there, and minus the sine theta over 2 plus 90. Okay, and we can combine, so that would be 3 theta over 2 half x squared 3 theta over 2 plus 90 minus sine theta minus sine alpha over 2 plus 90. Okay, and we can leave it like that. There are some transformations or combinations you can do to make it look different, but they haven't told us to do anything like that, so we can just leave it in this sort of expanded form. Okay, you could also remember that sine theta plus 90 equals to cos theta. Okay, so we can substitute that in, and that term will just become minus cos theta over 2. Okay, because the plus 90 just makes the sine into a cos. Okay, you can prove that graphically or algebraically, but we don't need to do that here. We can just, so that final answer will be half x squared 3 theta over 2 plus the 90 minus the sine of theta, and then minus cos theta over 2. And there is one thing with this answer, which is that the theta over 2 here is in radians, because we used the radians formula, but on 90 degrees, it's still in degrees. So to convert from degrees to radians, what do? We times by pi over 180. Okay, so therefore 90 times pi over 180 will be pi over 2. Okay, so this value should be pi over 2. And you could also remember that pi is 180, so 90 is pi over 2. Excellent, great. That's enough for this question and this topic.